the parental influence. Vivek always supporting him, and he's not a ham himself. Always supporting Rohan. And just like Galen comes with his own cheering squad here. That's important, showing support. That's another way to get the young people interested. Rohan, the floor is yours.
So, hi, I'm Rohan, KJ6LXV, and today I'll be doing a short follow-up on the presentation which I gave last year. And the presentation last year was about packet radio with smartphones. Since last year, I've made a major improvement, which is coming up with a name for the system. Because as much as I love acronyms, it really needed a name. So I named it Odin, after the Norse god. Also, Odin just sounds cool. So let me start off by reviewing what is Odin. Odin, the idea behind Odin is to act as a bridge between the world of ham radio and the world of modern consumer electronics, such as smartphones. And Odin uses packet radio, which is a digital mode for ham radio, and allows it to be used with all the simplicity and ease that you expect from a modern smartphone experience. Traditional packet radio isn't very simple. You have a giant clunky laptop and a really ugly UI. But the idea is that you can, with the smartphone, you can drive more young people to get into it because it's something that they're familiar with and it's elegant and simple. And one of the challenges that I faced while trying to get a ham radio to connect with the modern consumer electronics is that ham radio and smartphones, they use very different interconnection standards. Ham radio still uses things like serial cables, and those have been long abandoned in consumer electronics. You're going to be hard-pressed to find a serial cable on a modern laptop, let alone on a smartphone. So Odin also is the linking hardware between the radio and the user's smartphone. So this is a picture of the original Odin prototype, which I had last year and I showed and demoed last year. So this is made off of 3 off-the-shelf boards. There's the Arduino on the bottom. There's a Bluetooth low energy system, the Bluetooth low energy board over there. And on top of it, there's the Radio Shield from Argent Data. This Radio Shield is it does all the work of a TNC, so it does most of the heavy lifting of modulating and demodulating packet radio, and it can connect to the radio via an audio cable. And last year I talked about how I was working on a next generation hardware and using custom boards. This year, here it is. This is the new Odin prototype, complete with a case and a front panel, so it looks nice. Some of the new features are now it's all custom PCBs. There's 2 custom PCBs. There's a front panel. There's a better battery system. Last year it was just a USB cable. And it has a tunable antenna. It's tunable antenna. I can't tune it right now because I don't have a VNA. They cost something like $50,000, which apparently my dad won't just give me for a piece of test equipment I'll use once. So if anyone has a VNA I can borrow to do a quick test, that would be very... That would be excellent. So let me talk a little bit about the front panel. So I made a couple different versions of it, of the hardware. This is the version that can connect to the cheap Chinese import radios and Kenwoods, and those are they both use. I also have a version that works with Icom, and those, thanks to the radios that Ray gave me, I was able to test them, and it does work with that too. So this is mainly because these are the radios that I have a few of these radios. Anyway, so those two ports, those connect via an audio cable to a cheap radio, or or with a different version, a fancier Icom, and and then those lights over there, those are LEDs, and it's kind of cool because they are reverse mount. So they solder on the back, but they shine through the front of the board. That was a kind of interesting thing that I found, and I used those. And on the bottom, over there, that's the Odin logo. And in the corner on the bottom, that's my company logo. So it's Aliopile, and it's kind of a business thing that I set up for around this. So some of the things and challenges that I've experienced or faced since I've been working on it last year was modulation. It turned out to be a lot more difficult than I previously thought. So last year I had a working DMod was relatively simple, or relatively and I was able to use a generic algorithm I found. But for modulation, the main challenge is that packet radio requires a phase continuous wave. So generating that on a cheap 32-bit microcontroller was a little bit of a process, but eventually I got modulation working. And then the other thing is a bit of a mechanical problem, and that's alignment between the front panel and the main board. So these are the boards that go inside Odin, and I'll pass these around, but one of the main problems was challenges was trying to find a way to connect the two boards in a way that was cheap, because I don't want to spend $15 on a connector to go between the two boards, and also a way that allowed the audio cables to connect through in a reasonable way. So I'll pass these two boards around, and so the way that it connects is that there is basically two pads on each board, and I just solder them once they're in the housing. The boards are all surface mount for the most part, so I had to learn surface mount soldering to get, which was interesting, and but that way I was able to solder on the Bluetooth low energy chip, which is only available in surface mount. And finally, the challenge is the Bluetooth antenna. As I mentioned earlier, I don't have a VNA, so I can't tune it. And the other thing is finding an antenna method that works well for the RF front end on the Nordic, which is the Bluetooth chip. And I needed to design the RF front end without using expensive PCB design software, because professional PCB design software is very expensive, and I'm using cheap open source or just free open source stuff. So I use KiCad, and it works really well, but I can't just import the design files that they provide. So I needed to replicate the design and get it within the tolerances for the chip. I'm going to pass around two prototypes. One full in the case and everything. This is the display model. This one doesn't have parts in it, but it has the correct look. And this one, which is a functioning prototype, and this one has a bunch of resistors and wires added all over the place so that I can hook up signal generators and test different parts of the board. So some of the next steps I have to take on this project is I have to, again, antenna tuning. And one of the things I decided to do is put an actual switch on the battery. So things powered off a single AA with the boost converter. And it works, that system works quite well. And I'm able to drain the AA all the way down to 0.8 volts. So it starts out at 1.5, and I can pretty much get every last drop of juice out of the AA. But the problem is that within the case, getting the AA out of there is a bit of a challenge. So right now you have to fiddle with the flathead screwdriver and try and like push it out. It's very tight in there. So I decided to actually put a switch in there eventually on the next rev so that you can turn the device on and off and not just put it in sleep mode. It does last a long time on sleep mode. I had a battery in it for like 2 weeks, or not 1 week, and it just stayed at a relatively constant battery level. And then the other thing I have to do is field use. So I live in Cupertino, and we have an Aries Races program in Cupertino, which I'm involved with. And one of the things that I did in preparation for last year's presentation is I presented Odin over there, and they were very interested in using it as a way to have decentralized text-based communication in case of emergencies. So I'm working with them to try and deploy Odin for the annual drill that we have in May. So I'm going to try and get a few of these units out there and deployed and in use in the field, so I can get feedback on how it works and things I need to change. So that's everything for my slides. Those are thank you for listening and having me again. And that's my email address and my LinkedIn profile. Any questions? Over there?
Well, you mentioned Odin. When is Thor coming out?
So I don't know what I'm going to call it, but one of the things I was thinking about is doing a similar system without the ham radio component and make it more consumer electronics and like decentralized texting without bars kind of idea. So you can text without any kind of infrastructure requirement using MERS, which is a North American 2-watt, 150 megahertz unlicensed band. So that might be Thor, but not sure.
Yeah, Rohan, give us a little personal update. What are you doing academically and in your personal life now?
So now I'm a freshman in high school. I go to Monte Vista High School, which is pretty close to here. And some of the electives I'm taking are taking electronics class, which is fun, easy. And then there's I'm also taking Chinese, which is still fun, but not so easy. And
Ni hao.
yeah, I'm taking Chinese because that way I can use the really cheap electronic parts where the data sheet only comes in Chinese. So I'll be able to use those. Yeah.
I do seminars around the world how to watch out and dealing with Chinese companies so they don't steal your ideas. So before you do anything overseas, let me know. I'll give you my free services. Question for you: have you done some costing? You're going into the next level. Have you put together a projected price for this invention of yours?
So projected price is based on the cost of the bill of materials, and I haven't factored in assembly cost, but I'm sure I have to factor in some amount of cost for having me screw it together or have someone else screw it together a bunch of times. But projected cost of sale is $50, which is significantly cheaper than a packet TNC, which is somewhere around $200 for a desktop TNC. But based on the bill of materials, it looks like the wholesale cost would be $50.
Very good. I'll suggest you bring it up to $99, and you can always discount. Okay?
Yeah.
So that's a suggestion for me, and my company would be interested in giving you a little project and a little non-recurring engineering fee to modify this little product for something that we are actually having someone design for us, and you're already 99% there. So we'd like to entertain an opportunity over some period of time and getting this into the commercial marketplace for something that we already have developed on software. So just very good.
I'll have to make sure that you get my business card then.